Okay, so welcome back. This is part 2 of the exponents review, and so what we're going to do is continue here with question 11. So now we have a given function g of x, and we've been asked to evaluate each of the following. Evaluate meaning find the value of, and so hopefully you recall from function notation these are substitution questions. So g of 0 means in the place of x we are going to substitute in a 0, and so we have 2 multiplied by 3/4 to the power of 0. You can type this directly into the calculator, or in fact use the graphing function on the calculator with the trace. In this case it's relatively straightforward, so we're just going to go ahead and do these calculations manually or in our head. So 3 to the power of 4 is in fact 1. Anything to the power of 0 is 1, and so we're left with 2 times 1, which gives us 2. G to the minus 1, 2 multiplied by 3/4 to the power of minus 1. I'll show the first step. That's going to be 2 multiplied by 3 to the minus 1 over 4 to the minus 1, which is going to give us 2 multiplied by 4 over 3, because of course anything with a negative exponent moves, so the 3 moves to the bottom, the 4 to the top, and I get my final answer of 8 over 3, or if you typed it into the calculator you can use a decimal. That would be fine, and that would give you an answer of 2.66 recurring, or 2.67 if you round off. Again, watch out for order of operations. It's 2 multiplied by and then an exponent, so we do need to deal with the exponent first before multiplying by 2. For g of 3, 2 times 3/4 to the power of 3, and so that is 2 times 3 cubed over 4 cubed, which gives us 2 multiplied by 3 cubed. 3 3s are 9, 9 3s are 27, 4 4s are 16, times 4 is 64, and we can write our final answer as 54 over 64, because it's 2 times 27 is 54 over 64. Essentially we're multiplying by 2 over 1, and so that's how we end up. We can simplify, write a decimal, or just leave it as is. And then last one, g of minus 3, 2 multiplied by 3 to the minus 3 over 4 to the power of minus 3, 2 multiplied by 3 to the minus 3 over 4 to the minus 3. Flip that upside down essentially, but not the 2, because the 2 does not have a negative exponent. So we have 2 multiplied by 4 cubed over 3 cubed, which is 2 multiplied by 64 over 27, and this time the answer 128 over 27 as our final answer for 11D. Okay, now we have word problems, an application of the exponential functions. We have our car, which is bought for 10,500, and just one quick thing to look at here, and this will be consistent in the exam as well. Oh, actually I haven't put it on here. You'll see this when you do the mock exam on later this week. You will be given the formula for exponential growth and decay, which looks like this. F of t is equal to a times 1 plus r to the power of t. A is the initial amount, r is the rate of interest, t is time in years, and of course this would become 1 minus r if it was exponential decay. In this case it's written as the exponential growth, but essentially we can determine that from the question to know whether we are using plus or minus. So here we have 10,500. That is our A value, the initial value of the car. The car is losing 7%, so that's our R value, and the fact that it's losing means we're going to make that R value a negative. The first part of the question says write a function which models the value of the car as a function of time, and so we're going to say f of t is equal to 10,500 multiplied by 1 minus 0.07 to the power of t. We can simplify that a little bit if we wish, and so we could write f of t is equal to 10,500 multiplied by 0.93 to the power of t. That would be our function. The second part is asking you to find the car's value after a specific amount of time, in this case 8 years. And so essentially what we're doing is finding f of 8, which means we are substituting 8 into in the place of t, which is our time. And so what I need here is my exponent to be 8, and I'm going to type that into the calculator to work out the value. So I have 10,500 multiplied by, so I'm just going to use a set of parentheses, 0.93, and that is going to be to the power of, and in this case you could also put that power outside, belonging to the parenthesis, because the 0.93 is in the parenthesis, to the power of 8, and we get 5875.60. And what we're going to do, since we're talking money in this case, we're going to round to 2 decimal places, and so the value of the car is 5875.61 if we round to 2 decimal places. Of course, there could be extension problems on this very easily. You could be asked to calculate the total amount lost from the time the car was bought to now, and those kinds of things, or be given different amounts of time. Okay, so we're going to jump ahead to the next types of problems, and so what we have here are questions that ask for you to find an equation, so an equation in the form a times b to the power of x, and what you essentially need to do is, given these points, you need to figure out whether it's exponential growth or decay. We need to find the value of a, and we need to find the base. Okay, so again, what we need to do first is isolate any one of the given points. In this case, we are going to isolate 0. That's the easiest. We're going to substitute that in. F of 0 is going to be a multiplied by b to the power of 0. So that's the x value substituted in, and the y, this is the value of y, which is the f of x, and so that's going to equal 6. And essentially what this allows us to conclude, b to the power of 0 is 1, so that effectively has no impact, and we get a equal to 6, and so we have found the first of our 2 pieces of information. The second thing we need to do is to be able to determine what the base is. And the way we're going to do that is starting from the left, the smallest number. If I go from 24 to 12, that requires that I multiply by 1/2 or divide by 2. From 12 to 6, I'm multiplying by half. From 6 to 3, I'm multiplying by half. And you can see very clearly that the pattern is, in each instance, you're dividing by 2 or multiplying by 1/2. And this tells us that 1/2 is the value of b. And so we are now in a position to write our exponential function as 6 multiplied by 1/2 to the power of x. Okay, question 14, same question, exactly the same question, and the same procedure. And so once again, f of x is equal to a times b to the power of x. What you can see, in fact, is that if you're given a point with a 0, that the corresponding y value is essentially going to be the a value. So we can cut to the chase a bit quicker here. Straight away we can determine that this is our a value, and so we have a function f of x equals 2/3 times b to the power of x. We now need to determine what b is, and in order to do that we're going to see what pattern emerges as I move from the left to the right. So I go 1/6 to 1/3. Well, we get that by timesing by 2, 1/3 to 2/3 times by 2, 2/3 to 4/3 times by 2, and so forth. And so my function is 2/3 multiplied by 2 to the power of x, and that would be an example of exponential growth because the base is larger than 1. Okay, last question now on the, I beg your pardon, second last question on the exponents. So we do have a graphing question. That's good. I mentioned earlier we didn't, but I'm glad we do. And so in this case, again, a word problem. Very similar to the previous one, only in this case the value of the apartment is increasing, and so we have exponential growth. Okay, so like I mentioned before, this function is going to be given a times 1 plus r to the power of t. We are going to have to figure out exactly which parts of the given information fit into which pieces of the formula. So the house was bought for 142,000. That's going to be the initial value. 6.2% is the rate of increase per year. That's going to be our R value. And again, in this case, it's a specific time value. But what you'll see from question A is that you've been asked to write a function that represents the value of the apartment as a function of time. So we're going to begin by saying f of t is equal to 142,000 multiplied by 1 plus 0.062. So 6.2% we divide by 100 to get us a decimal to the power of t. Okay, in this case we have this is called the growth rate. The growth factor is just the value of the entire parenthesis. And so the growth factor in this case is 1.062. That's the number you would multiply by each year to figure out how much it's growing by. And so if we're going to find the value of the apartment today, that's when we need our 15. It's f of 15 is equal to 142,000 multiplied by 1.062 to the power of 15. And we'll type that into the calculator. 142,000 multiplied by 1.062 to the power of 15, and we have the value of the house 350,070 and 97 cents. So 350,070.97 corrected to decimal places. Okay, and very quickly we're going to move on to the last problem, which is in fact using the calculator to sketch a graph of the following function: 1/2 times 2 to the power of x. So we're going to go into the calculator. I'll go to the home page. What I'm going to do is just go back into the document I was using before, and I'm just going to add a page. So essentially we're opening a graphing page, and I'm going to enter the function in over here. So 1/2 0.5, and that's going to be multiplied by, in parentheses, I'll put 2 to the power of x, and I'll close, oopsie, that's not what I wanted to do, 2 to the power of x, and I'm going to move outside the parentheses, hit enter, and we've got a sketch of our function over there, which you would now need to translate. One of the things you could do on here is you could look at the menu. If we are using the trace button, we can slide along and get the coordinates of different points in order to plot on our graph. And so if I come back over here, we're going to be able to get the shape. You can see that the y-intercept, you can see from the graph, is going to be at 1/2. You can see that the function is going to be an exponential growth function. If I come back over here, what I'm interested in doing, let's say, is getting at least one other point. So we have the point right over there, right about 2, x equal to 2 and y is equal to 2. And so I'm going to read that off the graph. X is equal to 2, y is equal to 2. And then what I'm going to do is use a hopefully smooth curve. Do not use a ruler. I'm going to make sure I pass through those 2 points. Arrows at both ends because the function continues forever. Labels, x is equal to 0, y is equal to 1/2. Label for at least one other point. I've chosen the point 2, 2, and this is the function f of x. And of course we could easily determine domain and range as well if we were asked to at this point. Okay, and that's the end of exponents.